For our last example in section 2.3, I'd like to take a look at an example, and I'd like to do it entirely by hand, and I'd also like to remind you of what it looks like if we did some of the work using Desmos. So let's see here. We were down to our very last example, example 4 here. And we have the number of people living in extreme poverty, defined as less than 1.90 international dollars per day, just a monetary unit to equate different currencies. And that number of people living in poverty has declined approximately linearly, so they're telling me it's going to be a linear equation, since the year 2000. In fact, in 2002, there were 1.61 billion people living in extreme poverty, and by 2015, that number had dropped to 0.7335 billion. So, T is supposed to represent the number of years after the year 2000, and we're looking for an equation for P of T, the number of people living in extreme poverty. Unfortunately, in this example, unlike the previous one, they didn't kind of give me the M and the B in the description. The rate of change, the M, is not stated here. And even the B, since T equals 0 is going to be the year 2000, I would have to know the number of people in poverty in that year to find B. And they gave me 2002 and 2015. So they didn't help me out much there. In a case like this, what I like to do is create for myself just a short little table of values that's going to actually help me organize the information. So I'm going to say T, my input, is the years after 2000, and P, my output, the number of people living in poverty. And they told me 2002, which would be 2 years after 2000, the number of people was 1.610 billion. They also told me in 2015, so T equals 15 there, we have fewer people in poverty, 0.7335. Now that my information is kind of organized in that table, it's just easier to work with mathematically, and I can start looking for a linear equation. Now I'm going to need to figure out both the M and the B. So to calculate the slope, the M, I'm going to do the y2 minus y1 over x2 minus x1. So 0.7335 minus 1.610 divided by 15 minus 2. Divided by 13 is 15 minus 2 on the bottom there. Negative 0.0674. So that's my slope. One thing that students often ask me is how many decimal places should they be keeping as they calculate these values? And there's no real hard and fast rule. If it really matters to me, I would have to tell you in the problem. But I'm going to tell you the rule of thumb that I kind of use. You might notice over here these values, there were 4 digits in each of those numbers, right? This one and this one. So I kept 4 digits in my slope. It's sort of similar to the idea of significant figures that science teachers use. Mine's a little looser. I'll let them talk to you about the very specifics of significant figures. But that's kind of my rule of thumb. I kind of try and be consistent within the problem. All right, so I know M. I now need B. I don't have a T equals 0 here, so I can't just grab it off the table. I'm going to have to go back to the equation of the line. Just to get the B, I'm going to go with y equals mx plus b. Eventually, I'll change to the T's and the P's. But I'm going to plug in a couple of values. My input and output pair here, I'll use for the x and the y, and then the M that we already calculated, I can plug in. So my equation becomes y, 1.610, equals m, negative 0.0674, times the x, 2, plus b. All right, a bit more arithmetic to do here. That is negative 0.1348. And then I'll have to add that to both sides. To get b. And I have 1.7448 for my b value. So now that I know both m and b, I can write my equation for my function. So p of t, the function I'm trying to find, is going to equal my slope, negative 0.0674 times t, plus the 1.7448. Sorry, I didn't organize my space very well. I had to squeeze that in over there. So there's our p of t. All right, part B of this question asks us to find the zero of the function p of t and explain what it means in the situation. Answer the question, do you think that's realistic? We talked just a little bit about the zero in the previous video. The zero is the value of the input, so the t value, that makes the function zero. So basically, I want to take my equation and put 0 in for p of t. I'm going to add the 0.0674t to the other side, actually to both sides, but it makes it positive over here on the left. So equals. And then I have to divide by the 0.0674. And I get about 25.9. If I want to round off to the nearest whole year, I could call it about 26. So we're at about by the year 2026. P, the number of people in poverty, has become 0. Now, given that we're very close to that year now, just a couple years away, right? Do you really think that's realistic? Unfortunately, it probably is not. So at this stage, I think this is probably unrealistic. Our model is probably broken down by now. Before we stop this section, I wanted to remind you that unless a problem specifically says you have to solve by hand, some of these kinds of things can actually be done on Desmos as well. We haven't looked at Desmos for a section or two. So let me go into Desmos, and I'm going to put my P of T function, my poverty function, in Desmos. And let's take a look at the line that represents the number of people living in poverty. So there we go. And I'm actually going to put my x-axis just a little bit. There we go. All right, so you can see that the number of people living in poverty is decreasing as we expected, right? We saw that with our numbers in the problem. And it is linear, the equation of a line, that makes sense. The zero of the function where p is 0, let me label my axes. The input was t, the output was p. So where p is 0, the zero of the function happens out here. And notice that's the same value we got by hand, about 25.9 or almost 26. In 2026, the prediction is the number in poverty is 0. So I can see that off of Desmos as well. Also, once I have this function, if I was interested in a particular year, I happen to be making this video in 2022. I'm not sure when you'll be watching it, but I could put P of 22 and get a prediction for this year. Prediction is 0.262 billion for 2022. Right? So I can do all kinds of things very quickly and easily again, if I allow myself to use the technology. All right, that's the end of 2.3. So we'll stop there until we come back next time for section 2.4.